2 hours to get to you, but I just wanted to remind you all of a couple of things. We have the Q&A button on the bottom. If you have any questions that come up, we have Yvonne Tarin, who's on the 1s and 2s. He'll answer as best as he can. If for some reason it needs to be kind of taken up to the next level, we might be able to address it at the end. And if not, we will definitely save it for tomorrow, because tomorrow at 9 a.m. Pacific time, we'll be doing our Q&A with both Bella and Alexi, and they'll be answering all of your questions and talking a little bit more about what is discussed today. And so it'll be a really great way to kind of round out all the information that is given, and give you an opportunity also to expand your questions and take it to the next level. So with that, we will be taking a break somewhere around the top of the hour, around 10 a.m. Pacific. So just know that if you do have to use a bio break, try and save it for that 5-minute break. And I might be popping in and out just to kind of check in on everybody during the time, but that's just kind of the name of this online game. And I think that's all I have to say in terms of news and updates for everybody. I'm just excited to get into this, the nitty gritty, as they say. And so, yeah, please, without further ado, Bella, Alexi, take it away.
Thanks a lot, Bob, for this amazing introduction. Alexi, do you want to share your screen?
Yeah, I'm sharing right now.
Cool, awesome. Oh no, sorry, get away. All right. So we are introduced, and we're both software engineer at VMware. We work on the Spring Cloud commercial team, and our team is aiming to deliver off-the-shelf, easy-to-adopt Spring Cloud experience on different cloud platforms. We need to write a lot of tests, making sure the code works, the cloud platform integration works, and the user experience is as good as we expected. And we would like to share some of our experience with you all today with a model called Testing Trophy. Here's the link to our sample code project. If you'd like to follow along, feel free to do so. Otherwise, let's get into our talk. Why Testing Trophy? Why? Don't I already have a testing pyramid? Well, testing pyramid has always been the model for designing a test suite, and test coverage usually based on a lot of unit tests, which test each individual unit works as expected. A unit is normally a method or a function that could encapsulate some business logic. Unit tests tend to be tightly coupled with implementation and make it very hard and cumbersome to refactor our code. And we don't gain a lot of confidence by seeing all unit tests pass, because there is no assurance on the collaboration of the units. The good side is they run lightning fast, and a failing unit test gives us a strong signal on what's wrong in the code. To the opposite end on the spectrum, Alexi, do you mind clicking one more time? Oh, sorry. Les, I was looking at the wrong screen. Never mind. This is good. Yeah. To the opposite side on the spectrum, we have end-to-end tests to test the application from the user's point of view. Given certain state of the application, when the user provides certain input, then we should get certain observable outcome. This makes end-to-end test the ultimate truth during refactoring, because they don't care about the implementation. So they should just pass without needed to be updated. To meet this goal, we expect to run application with nothing mocked out, integrate with real infrastructure, test instances, or realistic fakes. And we need to simulate user input with a browser driver if there's a front-end piece involved. That makes end-to-end tests slower and harder to run, and provide low signal, high noise on what's actually went wrong when any of them fails. We all know from our years of life experience that we should try to avoid extremes and always seek a good balance, right? So to balance these two extremes, we have integration tests that verifies multiple units works well together and are delivering outcome based on events or inputs collectively. Sometimes it's also called component tests, meaning treating multiple vertically sliced units as a logical component and test them with mocked boundaries. Although integration tests seem to be a good middle ground, but the execution speed was not in favor of it in the past. So unfortunately, we had to put more weight on unit tests instead of integration tests in the good old days. But technology is constantly evolving, and applications are getting smaller and faster. We don't need to sacrifice confidence in the code for the sake of speed gain anymore. For those of you who follows trends in JavaScript, you probably have heard of or experienced the productivity boosts in UI testing when Puppeteer came out in 2017. Puppeteer was a WebDriver created by Google that goes really well with Chromium, which is also released by Google. They made it possible to run UI tests really fast and reliable, both locally and on CI. Front-end frameworks are also getting serious about testing and tend to have their own testing frameworks that can facilitate more modular integration tests. For example, Jest for React. So Kent C. Dodds brought up a new concept in 2018 called the testing trophy. In this new model, he suggested to write more integration tests for the ease of refactoring and introduced static analysis to ensure type safety, which further reduced the need for unit tests. Although Kent suggested to use Jest for React integration tests, I actually enjoyed doing integration tests by mounting submodules on the DOM when I do front-end work, because that allows us to even switch front-end frameworks without changing the tests. But that's just a minor variation of how to write integration tests. The main idea of testing trophy makes sense to me and really influenced me till this day when I'm mostly working on Spring. And if you dig more on it, the Spring ecosystem actually have all the pieces for you to adopt the testing trophy. Next slide, please. Sorry. From bottom up, we have Java or Kotlin compiler that stabilize our trophy. And due to the typed nature, we don't need as much static analysis as with JavaScript, but there are still checks that can help us avoid unnecessary bugs and edge cases without needing to write unit tests for. Spring Boot test annotation and test slicing makes integration tests easy to set up and run with boundary marked. We'll expand on that topic later. Libraries like test containers and Spring Cloud Contract makes it easy to test against the more realistic dependencies, even if you don't own it for a full end-to-end. Aside from the main body of the trophy, I would also categorize the ears as add-on optional external tests, or sometimes called enemy tests. If you can't run your end-to-end tests against a realistic test instance of your API provider, then you may want to have some external tests that validates your assumption about that API periodically. For example, the transformation they promise to do to the data you send them. The goal is to have a red pipeline when your assumption about the external API is no longer valid, so you can catch it before your users do. And this is our trophy. Beautiful, isn't it? Alexi, to you.
Yeah, sorry. I was just trying to remember to click unmute before I start talking because, that happens nowadays. Yeah, thanks for the great introduction. So let's talk a little bit about code analysis. As you noticed already, it's not that maybe important in static languages, in statically typed languages like Java. And because the whole kind of testing trophy approach, it started in JavaScript world, that was pretty fundamental to actually run it before you run your unit tests. Because in a dynamic and weakly typed language, having more static code analysis checks, that helps you basically to catch errors and problems in your code, which you don't even know about. Like make sure that all the properties on the object, they exist before you're trying to access it, or maybe something you're calling is actually a function and not a string, which also possible in JavaScript. So that was pretty fundamental, and due to dynamic nature of JavaScript in the original testing trophy approach. And that's why this kind of the foundation piece in a testing trophy is kind of significant and a large one. It is slightly different in Java world, because in Java, you already getting a lot of help and a lot of static checks from the compiler. Again, due to the nature of the language itself, you're getting the check of your correctness in terms of types, and you're getting like all the checks you can potentially get only from the third-party code checking tools in JavaScript for free in Java. Let's say you absolutely sure that you're not accessing properties of the object that do not exist, and you're not trying to run something that is not a function. So it's all validated for you by Java compiler itself. But on top of that, there is the whole kind of set of errors that which are not caught by Java compiler. Because I mean, to be fair, Java compiler is not the most advanced one. So it's fairly good, but as well comparing to other JVM languages, even like Kotlin, is not that advanced. And there are classes of errors you potentially want to catch and want to find even before you run any tests on your application. And let's say to name a few, it could be handling null values in your code, so-called null safety. So basically, when you call, when you pass the values around in Java, you can have instead of the value, you can have null. And as you know, that in a time and a place where you absolutely don't expect, you're going to get this null reference exception, and your users will be unhappy by getting the server error page instead of the page they're looking for. So and that's something that is not analyzed by Java compiler, but analyzed by other JVM languages, let's say Kotlin. But you can actually get it in Java as well, and we're going to get to that in a second. But even apart from null safety, you can validate a lot of aspects of your code without running any tests, without running your code even. Let's say thanks to GitHub, you can now security analysis of your code using the security scanning provided by GitHub. And you can basically get a library of the potential vulnerabilities provided by the library author. So you can check that, you know, if you're running Netty, that you don't have any anti-patterns which are potentially insecure. So you can even run, in addition to like security checks and null safety checks, you can even check the architectural consistency of your application. So you can validate that, you know, you're not accessing one module from another using some internal mechanisms or internal parts of it. So your structure of your application is correct using tools like ArcUnit. And many more, actually. So there are plenty of tools for Java to run static code analysis, and there are many tools you can that can help you with that. So as I said, the number one tool you're going to be using is probably the compiler. Well, definitely the compiler. You cannot avoid that. And number two tool is your IDE if you're using one. So the advanced Java IDEs like IntelliJ and Eclipse and NetBeans, I think even VS Code, they can do some analysis for you, and they can help you to identify potential problems with your code. But because we're talking about continuous delivery and continuous integration all the time, we want to run some checks in your pipeline, not in your IDE. So you want to make sure you want to basically enforce these static checks in your pipeline rather than make it optional in your IDE. And there are tools to do that as well. So one tool I'm going to talk about today is called Checker Framework. And it's basically a collection of different static code analysis rules for Java. But I'm going to talk about just one of them, about null safety, because it's for the demonstration, it should be enough, but you can get the idea how it works. So to do that, I'm going to be using an application called Animal Rescue. So this is an open source application. It's available on GitHub. It's basically on my account at the moment, but it's a fork of the application Bella and I are using to demonstrate the project we're working on, Spring Cloud Gateway. And we use this Animal Rescue application as a demonstration, but we decided to adopt it for our talk as well, because it's a fairly standard Spring Boot application with React frontend. So it has multiple components. It has a frontend written in React and JavaScript. It has a backend in Spring Boot with accessing some data in a relational database, having some Spring Security integrated. I would say a fairly standard setup you may see in a lot of projects. So the application itself is quite simple, but it should be enough for the purpose of our talk. So I'm going to run it now. And so just to show you around quickly. So this application, as I said, it's available on GitHub. So you can basically clone it and run it locally if you want to play with it. And if you want to follow along, just I think there is a link on the first slide, but you can easily find it in GitHub on this URL, which is github/alec-sys/animal rescue. Right, so I think it is started now, hopefully. Zoom is probably one of the most CPU inefficient applications on my laptop, so it's taken a little bit of time to start and
Plus
share
IntelliJ.
Plus IntelliJ.
Plus
I'm not
Docker.
blaming IntelliJ.
Plus Kubernetes.
And just that. Right, so this is the application landing page. This is the main page. As you can see, this is an application for a made-up animal rescue center where you can adopt one of these animals waiting for adoption. So it actually started as a kind of, not a copy, but as a tribute to Pet Clinic, which is a standard test application for Spring. But we decided to do something similar but different. So hence Animal Rescue. So yeah, as you can see on the main page, we just see a list of animals, and this is it's coming from database, and this is React.js getting the data from backend in Spring Boot by using REST API and displaying some data. We can see basically, picture, description, and a number of pending adopters, which is basically adoption requests. And we can also add another adoption request. But to do that, we need to sign in. So we just click this login button, we type our username and password. So we have 2 test users you can use. So when we log in, now we can basically adopt one of these animals. So we can just put our email, email.com, and then say something. Right. So this is how it works. As I said, we can also edit or delete this adoption request. It's fairly simple. It's pretty standard in terms of like technology stack, and that's why we picked it for our demonstration. So let's see how it looks like in IntelliJ. So I'm going to switch to IntelliJ. I'm going to close all of that for a second. So as I said, at the moment, we're going to be talking about static code analysis in Java. So I'm not going to touch on static code analysis in front end. There are plenty of tools. But let's say what we have in Java. So this is our structure of our project. And there is one project called backend. I'm not sure you can zoom in on a side of that, but hopefully you can see it. When I jump to the code, it's going to be much better. So just bear with me for a second. So in a backend application, I do have my build.gradle project because we're using Gradle to build this application. So, and in here, one of the plugins I have, in addition to traditional Java and Spring plugins, is the one called Checker Framework. And that basically enables integration with the Checker Framework. So the version number is quite low, but that's just the version of the plugin. The Checker Framework is quite mature and advanced framework. So, and then I can configure it as well. So I basically say, let's say I want to configure only nullness checks from my code base, and I don't want to don't want to check my test code at all. I mean, that for test code, it's fine, but you can totally enable it as well. And let's have a look at the example, what it can do for us. So in the code base, there is one class called adoption service. And this adoption service is a kind of a business logic between the controller and the database. The application is, in fact, so simple that in most cases, we don't really need any of these services or complexity. So Bella and I would try to kind of make it a little bit more complex, a little bit more interesting, just to show you around. So, and in this service, I have a method called update, which takes an adoption request and an animal ID, and it basically updates an existing request with new details. So let's say if you want to change your email or if you want to change your notes or something, you can just go there and change it. But what is interesting is, I'm going to zoom in a little bit more, is this non-null annotation on the animal ID parameter. So this non-null annotation is actually coming from Spring Boot, from Spring code base. So if I go to the definition of this one, as you can see, that actually exists in the org.springframework.lang namespace in the package. So this means it's part of Spring. You can use it in your Spring application for free, and it's available out of the box. The reason of doing that is because this non-null and nullable and everything else is part of never released JSR 305 annotation, which is, I think, from 2006 in a dormant state, and the chances that it will be released are fairly low, I would say. So it's not part of OpenJDK release. It's not part of any. It's part of a library, so you have to bring the library if you want to use this annotation. But good news, Spring already provides that, so you don't have to add any more dependencies. So what we've done here, we said to our tool, like I'm saying a tool, because any tool can read that. It's not just IntelliJ, not just Checker Framework, not just Spring. It's just plenty of tools can read these nullable annotations. So I said that actually I'm not expecting null as a potential value for animal ID. So let's see where I'm actually calling this method. So I'm calling that from the controller method. And in here, I'm actually receiving this animal ID as a path variable as a part of the URL in the original request. So by default, these path variables are all mandatory. So you cannot, that's not possible not to provide the value for that. Otherwise, Spring MVC will just throw an exception. But let's make it optional. Let's say this is not required. It doesn't make a lot of sense from the kind of business standpoint, but again, pretend it does.
Demonstration purpose.
Demonstration purpose, exactly. So, and in here, I'm saying that it's not required, but in addition to that, I also need to tell that it's not just not required, but it's also nullable. This means that potentially this value can be null, and this means, but this method does not accept any nulls. So normally what you would need to do, you would need to write a test for that. If I pass a null to this controller, then when I call this adoption service, I receive null and I handle it properly and I throw an exception or don't throw an exception or do something. So in quite a lot of cases, you do need to write a test for that. But in case of using static code checks, advanced static code checks, you don't need to do anything actually. Let's say if I run compile Java task, if I just try to compile my project, what is happening? It is doing a flow analysis, and it actually, by it, I mean a tool. In my case, it's a checker framework, and it says, "Ooh, seems like your method is expecting non-null variable, but you are passing nullable variable in here. It's not going to work." You can also see that IntelliJ is actually giving you a hint that that potentially argument may be null. So you need to do something with that. So let's try to fix it. Imagine I receive null and I want to fix it. What I can do, I can say if this value is actually null, then I'm gonna do something, right? In my case, I'm just gonna throw an exception, but you can potentially assign it a default value or do a redirect, like handle it according to your business logic. But in here, I'm just gonna throw a legal argument exception, and that's it. And then IntelliJ immediately understands, okay, now if we get to this point, it's already not null. And if I run my compile Java again, we're basically gonna get this code compiled and ready for testing. So thanks to that, we don't have to write any tests for nullability because we can just run it using the static code checks even before we run any tests. So this happens on the compilation phase, and that's already before you even start your testing framework. And that's the beauty of that. Right. So let's go back to slides. So that was an example of the static code analysis, and let's just move on and see what else we have in the testing trophy.
Oh, it's my slide. Thanks, Alexei. We have discussed that how can we have a solid base with static analysis for our trophy. Let's move on to the body of our trophy, integration tests and unit tests. There are different definitions of units, different definition of integration tests, and different schools of thoughts around testing. To keep this discussion focused and effective, let's define these terms first. Let's say a unit is a public method in a class that encapsulates some logic. For example, a method in this adoption service, like maybe the adopt method in this adoption service could be a common thing like that. Sorry, my cat is sitting on my keyboard. Get her off. Okay, now we're back on track. Then a unit test is a test calling this unit with all the outbound public method calls mocked out. Compared to that, integration tests are tests that don't mock all the outbound public method calls. In another word, testing the functionality of multiple units together. For example, a test that calls adoption controller, which then calls adoption service, which then calls a mocked animal repository. A test like this is integrating the first two services, mocking the last one. Integration tests can also be integrating with the infrastructure or dependencies. For example, testing animal repository with a database, a real database, to verify that a custom query works as expected. So next slides, please. Now, back to the question, integration tests or unit tests. This has been an ongoing war between two schools of TDD practitioners. The Detroit school advocates for mock nothing and test everything as a black box, while as the London school doesn't want to test the same thing multiple times, so they want to test that functional unit once in unit tests and mock it elsewhere. Just to make this interesting, let's start a poll. Marcel, could you please launch the poll for the audience, please? Let's understand where everyone where everyone is to see how everyone thinks about this topic. Coincidentally, I live in US, I'm closer to Detroit, and based on the topic of this talk, you can probably tell that I'm definitely not a London School supporter. Sorry, Alexi, I know you're in London, because I want you all to write more integration tests. However, I'm not a strict Detroit School practitioner either. I still see value in unit testing and mocking. For example, when a unit test needs to be tested with variations of inputs and is called from almost everywhere in the code base, I may consider using an abstract class to describe the common behavior at first. So all the integration tests that conforms to the same sets of behavior can just extend on the abstract class. But there is a point where the confidence I'm gaining from it is not worth the effort. Or that at that point, I may just break up the tests into a well-tested unit test and use a mock in integration tests. Think of it as using the same evolving architecture design principle to write and maintain your test code. We start with a simple Spring Boot test class and break them down when the complexity goes up. What about you, Alexi?
Well, as you can guess, I'm a fan of London School of TDD, but not because I'm in London. Yeah, as you said, basically, I think the main difference is like how much you mock and what is your test boundary and what do you test with the unit test or what do you test with the integration test. And I would say what I like about the Detroit school is because in a Detroit school, you get much more flexibility in refactoring. So basically, you're kind of testing the system as a black box. So you're free to refactor, let's say if you remove the service and replace it with a set of components, your tests most likely going to pass, right? Because you're testing that from the outside as a black box. But for me, why I like London School and why I like extensive mocking and introducing the really, boundaries between all the components and pretty much mocking all the components within the tests is because for me, TDD is not just a testing tool, but it's also a tool for designing the code. Almost like some people love to have like a pen and paper, just to write down their thoughts and ideas when they write code. They need to draft their thoughts, when they write some code. So kind of the same for me, but I'm using tests as a kind of my draft tool. So I like to ask my code questions, what should happen if I do that? What happens if I do that? And, we really want to be very detailed and a very low level on that because it helps us to understand how to write the code, how to structure the code, what should be the methods of your interface, what should be the fields on your entity and things like that. So that's why I like it basically. For me, it's more than just a testing tool.
Awesome. And we got our poll results. We have 50% on Detroit School and another 50% distribute to London School and other. I'm guessing other is just more like a variation, like somewhere in the middle of these two schools. And that's pretty much what we're trying to go today. All right. And as you can see, Alexia and I are not completely like aligned or like not aligned, more like we have our opinions on testing and we argue for this topic every time we bring that up, but we still work effectively together on the team because neither of us is dogmatic. And there are some key principles we agree on and would like to share with you. First thing is unit tests. Could you please click on it? Yeah, unit tests units in a unit test should not have any dependency on third-party or infrastructure code. Use a wrapper or adapter if you really want to separate like your business logic and your integration point. If you don't really want to do that, you can consider just write an integration test instead of a unit test that actually exercise the third-party code. And when you are writing tests for those wrappers, make sure you don't mock infrastructure and third-party libraries. Define the right inputs. Like for example, for a controller test, you should receive an HTTP request with a web test client or something, but not just a simple method call calling the controller method. If it's an outgoing HTTP request, run a fake HTTP server instead of mocking HTTP client library. That will definitely shield you from the integration point a bit. And continue clicking, please. Yeah. And for Detroit School practitioners, consider if you have no clue why your tests are failing, maybe consider adding some boundaries in your tests. So you get more like scoped integration, like you have some smaller scoped tests that helps you guide you in debugging your code, understanding your code. And click, please. for London School practitioners, consider using integration tests for parts of the code that is likely going to be changed. Otherwise, you're going to get into a hell, like you don't want to do refactor at that point because you just have so much unit tests you need to change. Cool. And next slide, Spring Boot test. Seems like I'm going to force a London School practitioner to talk about component test. To you, Alexei.
So yeah, I actually changed all the slides in the very last moment. You just don't know about it yet. So now we're going to talk about London School of Testing.
Oh no.
Yeah, sorry, I just messed up the slides a little bit. But yeah, let's talk about the integration testing then. So what we have basically, we all agree that in London School, in Detroit School, the integration testing is very important because in the end, what you expect from your test suite is to get some confidence that your code actually is working as you expect it to work. And whatever tool, whatever way you choose to do that, that's fine. But let's talk about integration testing. So in integration, when writing integration tests for Spring Boot applications, you probably already used many times the Spring Boot test annotation. And this is because this is ultimately your entry ticket, and this is your number one annotation you're going to be using when writing integration tests for Spring Boot apps. So I'm not going to talk about the details of that because, again, I guess a lot of people are very familiar with that. But let's instead talk about some tips and tricks that can actually help you to use this tool, to use this annotation better when writing component tests in your testing trophy test suite. So as we discussed already, it's super important, not just in testing trophy, pretty much in any approach to testing, is define testing boundaries and making sure that you're testing the right thing. The system under test is what you expect to be testing. So you need to define boundaries between your test and between your components, and you need to isolate these tests and make sure you can actually run them independently. So Spring Boot test annotation, although by default it just starts the whole application, and it's as you would normally do when you launch it in a java-jar or something in a command line. The same thing Spring Boot test will do for you. So it will actually start application context, and it will configure it using the older configurations and all the older configurations using the component scanning. So it will start the full-blown Spring application for you. And that's helpful and it's useful in many cases, but sometimes you want to fine-tune your application for testing, and there are many properties and tools you can use for that. So one I want to start with, well, actually two I want to start with, is changing the properties, because I think this is fundamentally one of the most common things you're going to do with when changing your application setup, is changing the properties of that. So as you probably all know, you can easily define new properties on your component test using test property source annotation. And starting from Spring Boot 2.3 and Spring 5.3, I think, you can also use dynamic property source annotation for dynamic properties. Let's say if you are starting external web server or external database or on a random port during your tests, you want to pass this random port back to your application context somehow. And this somehow is exactly this dynamic property source tool. It's super handy. Before you needed to use application initializers and do little hacks with the JUnit and the application context to pass it through. But now you can just use this dynamic property source annotation. So another one, now we're getting into introducing proper boundaries between your components, is of course mocking. So let's say when you're testing when we're talking about, let's say, animal rescue, when we are testing one component, let's say adoption request, we don't really want to test like the whole world, the whole of the application, and we want to test other business components, but not infrastructure. I just want to repeat that. So our business components with mock bin definition, and with mock bin, and that's why this is here we can use this mock bin annotation. So if you just put it in your test configuration, it will replace the bin with the mock bin. So you can also slice your test configuration into smaller chunks and define it on configuration classes. And when you start your Spring Boot test, instead of using the main Spring Boot application class annotated with Spring Boot application annotation, you can instead use one of the configurations and then import the extra configurations using this import annotation. So you can basically combine a required set of annotations on your component test when you need it. Of course, you can change the active profiles during your test using this active profile annotation. You can configure which profiles you want to apply when you're running a particular test, and that's how you can also like switch on and off parts of your application and components in your application. So that's a very handy tool as well. And the one thing I wanted to mention in the end is again, by default, a Spring Boot test annotation starts proper application context and starts the application for you, but it doesn't start HTTP server for you. So the embedded HTTP server is not started, and you can control that with a web environment parameter on the Spring Boot test. And again, this is super helpful when you're testing, let's say, HTTP endpoints, that you're actually sending a proper HTTP over the network and receiving the HTTP responses back. So let's talk a little bit more in more details about these annotations. So as I said, mockbean is the #1 tool when you're defining the test boundaries and component boundaries. So let's say in my case, when we're testing, let's say, adoption request service, I don't want, and imagine like it's not in a code base, but it's just completely made up. But I just wanted to show the idea. And imagine this is the service I created to, let's say send email notifications. So when adoption request comes in, I want to send an email notification that it's received. And when the status changes, maybe I want to send another email or something. So do I want my adoption request component test fail if, let's say, email is not available? Do I even want to start my email server or something to test adoption request? Probably not. So what I want to do, I want to instead mock my email sender component. And I think it's important to mention in this context, again, all made up, but in this context, email sender is a component I created as a developer of Animal Rescue. So I'm not mocking Java mail namespace or Spring classes for sending emails. This is purely user component. So I can mock that. And then in my component test, I can just say, okay, when the request when new adoption request comes in, I'm calling the method of this email sender, and this is our test boundary then. Sometimes this mockbean annotation is very powerful. So it's going to basically it's going to remove the original email sender bean and replace it with the mock implementation. So you can call it, so you can assert on that easily. But sometimes you don't really want to remove the original bean. You really want to call like the original method of something, but still run assertions that the method has been called with a certain set of arguments or something. So in this case, you can use, as an alternative to mockbean, you can use spybean annotation. And in this case, you can still call the original email sender methods, like send an email if you want to, but then assert that the method actually has been called, because the spybean definition will just keep this metadata for you. So that's the #1 tool for actually using for fine-tuning your application context in a component test and then isolating component test. Another one is actually using test components. So sometimes when you don't want to mock components, and let's say you want to introduce a test double or maybe some fake component, like imagine instead of a real database, you want to introduce like in-memory storage or something, you can use in-memory component. You can use test components for that. So because Spring Boot test annotation automatically starts your application and scans for all the components using component scanning, you probably sometimes don't want to do that. Instead, you want to have a component which is only discoverable and only used by a particular test. But if you create a component with a component annotation in your test code base, because it's going to be in a class path, it will be picked up automatically by all the component tests. So all your component tests will pick it up and configure it. That's why you probably not something you want. So in this case, you can annotate your components using test component annotation, and then manually just import that using add import annotation into your context for the relevant tests only. So let's say if you're testing again adoption request service, and if I want to introduce a test double for email sender, you can totally create a test component which implements email sender interface, and then import that into your component test and get a test double instead of a mock. So that's a very handy and a helpful tool if you want to configure your context in more details and replace some of the components to test doubles. So in addition to like set of tools to actually managing the application context and the component test itself, Spring Boot Test also provides you a set of tools for better integration testing. So let's say when you're testing your integration layer, let's say web integration layer. So when you're testing the request, HTTP request that come in to the application, you probably want to use some sort of test HTTP test client you can use to send requests to your application without any need to configure, let's say, a host name and port number, especially if it's a dynamic port number. So you just want to get something that is already pre-configured and points to your application, so you can just start using that. And that's exactly what this auto-configure web test client or auto-configure mock MVC does. So the first one is for the reactive stack, and the second one is for the traditional Spring MVC stack. So you can get a test client which is already configured to your application, and you can start testing your controller straight away. Well, let's say when you test the database, you sometimes want to, let's say if in a production database, if your production database is Postgres, but for the test, maybe you want to use not the embedded Postgres, but you want to use something simpler, like you want to use a memory embedded database. It may be a good idea, maybe not. We're going to talk about it a little bit later. But if you want to, you can use this auto-configure test database annotation on your component test to test against the embedded database. And there are a couple more actually, like test entity manager for testing JPA, or auto-configure cache if you want to disable cache in your component test and replace it with an OP cache manager. So Spring Boot gives you, Spring Boot test and like overall Spring test framework gives you a lot of tools actually to fine tune your component test, to your component test for the integration layer, to isolate the components properly. And so you can build test suite that actually fits quite nicely into this testing trophy approach. But what is important is because we put so much attention to integration tests in a testing trophy approach, that it's kind of inevitable that you're going to have a lot of integration tests, and the performance of this integration test suite becomes critical, because if you cannot run it quickly enough, it's basically kind of going to be in the same situation as end-to-end tests used to be. Everybody wanted to write them, but it was so slow and unreliable, nobody wanted to run them. So they were basically like write only. That's not something you want to do. Instead, you want to make sure that your integration test suite is running super quickly. And Spring testing support actually going to help you with that. So when you start for a new component test, when you start an application, it's going to be a proper Spring application. But let's say when you have multiple component tests and you probably do not want to start multiple contexts, multiple applications, in case if the setup is the same. And Spring testing support will take care of that. So when you're launching starting a new component test, it will actually try to analyze, it will build a context for you and then cache the context, the application context. So when the next time you try to run another component test, and this component test using the same setup, the same configuration, it will not start the new application. Instead, the test runner will just pick up one a test from the cache and then reuse that. So let's say when you have two component tests with the same application context configuration, the first one will take a little bit of time to start, let's say, I don't know, seconds, but the next one will be almost instant because it will be just taken from the cache. So the same configuration is a tricky bit. So what would you call a same configuration? So there is, of course, a list of things that the test runner considers to be the same configuration. So a set of properties and property values, a set of beans and profiles, and pretty much like everything that uniquely defines the Spring Boot application, it's going to be considered key for this cache. So that's important to remember, because let's say when you have two component tests and on one of them you have a mock bean for, let's say, bean number A, and on another one you have mock bean annotation for bean B, it's going to be two separate contexts, because mock bean effectively replaces the bean in a context. So you're going to have two contexts with two different beans, and it's going to start two applications and put them both in cache. So reusing the context becomes critical. So there are tools that can help you to reuse the context and make sure you're not starting context when you don't expect to do so. Let's say you can use a base class for that.
Maybe not.
Maybe not.
Testing inheritance is dangerous.
It's very dangerous. I would say it's very tempting to do so. It's very easy to do so. Sometimes it works, but it's quite quick. I've been there, and quite quickly it becomes just a mess. And we change one thing in your base class, and the whole test suite just crashing because the application context cannot start. I was like, be really careful with the test inheritance, especially if you see more than one level of inheritance, something is wrong with the test suite.
Yep.
So be
And
really careful.
Gradle can't really parallelize the test runs if you're using inheritance much.
That's another argument, actually. Yeah, so the tools you can do is just, I don't know, it may sound weird, but just be careful and, just consider carefully the context you're creating and make sure that you're not hitting the, the limit of caches or something.
Yeah,
You
and
can also
another
use
thing.
meta.
Oh, yes,
Yeah,
please continue. I was just about to
Yeah, I
add
just
that.
wanted to quickly say that if you only want to share, let's say, a set of properties, or let's say a set of annotations, or like this, auto configure embedded database or something, you can also use meta annotations. So you can create a meta annotation and just reuse it everywhere in your tests to make sure that you're not starting the context without need.
Yeah, or like JUnit 5 extensions, you can always use that to manage your context, like shared setups, shared after all, before all, that kind of things can be handled with JUnit 5 as well.
Yeah. I think I wanted to talk about, and we wasn't sure until the very last moment. Do we want to, tell this little dirty secret? But actually, sometimes you want to force the test runner to not to cache the context. Let's say if your component test, for whatever reason, is changing the context, modifying your application context in any way, you don't want to reuse it with anything else. You want to basically create it, run the test, and then discard it. And that's why you may need to, you can use this dirty context annotation. But it's extremely rare when you need one. So if you need one, just think twice if it's actually the case of if it's actually a business logic to modify the state of your application context, or if it's maybe a problem in your application structure or application architecture. So there are cases you may need to use. It's extremely rare, so be careful with that. And of course, it kills the performance instantly, because every time you have dirty context on your test class, it will automatically not cache that, and it will restart it every time you run an integration test suite. All right, so we talked about how can we introduce test boundaries between your tests, between your components. So how can you run isolated component tests that are, pretty much standalone and can fail independently? But sometimes, especially when you're writing integration tests for your infrastructure layer, for what we called for this talk, I'm not sure if it's a common term or not, edge components. So let's say if it's something in your front-end code in your UI layer, like a controller, or maybe this is something that is connected to the database. And if you want to basically test that in more details, and you don't want to use the component test for that, you can use what is called test slices in Spring Boot. So the reason, like, you may ask, why do I want to write a component, not a component, but the slice test instead of a component test, if the component test is our number one tool? Well, sometimes you really want your component test to be independent, and sometimes having some infrastructure concerns in your component test can actually break all of them. Imagine, like, consider, let's say, a security setup for your application. So when you're running adoption request service tests or adoption request controller tests, of course, it is all secure. It requires user to be authenticated, and the user needs to go to the login page and type the username and password. But do you really want to do it for all of the component tests? And imagine your login is broken for whatever reason. So do you want all the component tests to be read? Most likely not. You probably want to see a single failing test saying, okay, your login is broken. So your system, the overall system is fine, but the login is broken. Tiny little detail, the user cannot log in. But you still don't want to see like the whole test suite red and everything is ruined. You just want to see if one failing test, and that's why you can use these test slices. So you can push this kind of more extensive testing of the edge concerns like security, validation, maybe some complex logic in like saving something to the database, maybe complex SQL queries or something like that. You can push it into the test slices. because the test slices, the idea of test slices is actually test only a slice of your application. And a slice could be, let's say, a data JPA test. It means do not start the whole application and only start the components in my application relevant to a data JPA integration. Or the same for, let's say, Mongo test. Do not configure anything but Mongo integration. Not even controllers, not any user services, nothing, no components at all, no component scanning, is just purely integration setup. And let's say the same you can do for mock MVC or webflux test if you're testing the web layer. So you can nicely isolate the edge concerns, edge components in your application, and test something specific to this edge component in a slice tests. And this is a very powerful tool, but it's also, I wouldn't say limited, but it's a very specific one because, as I said, it doesn't do, let's say, component scanning, right? So you don't need, you won't get your components auto-configured. You won't get your, let's say, the whole of your application auto-configured. So let's have a look how it works actually. Oops, jumping in front. So I'm gonna go back to the same application, and I'm gonna remove all of these nullability things. You know what? What I'm gonna do is I'm gonna, oops, stash my changes. Cool. So we back to the original state. And I'm gonna show you an example of the component test we have. So this is an animal component test. So this is testing a component, and now in our case, the component is actually kind of a mix of animals and adoption requests, but that's fine because this is our component. This is our system under test. So we're testing the response from, let's say, animal endpoint, and we're also testing all adoption requests. So we're testing that we can actually send an adoption request and successfully create one. We can we get the error if we try to change the owner, like plenty of concerns. And it's all, as you can see, it's a black box testing. So we just sending requests to the application using HTTP requests, and that's it. We're not mocking anything, I think. Hopefully.
We're also not checking the state of the application.
Exactly. We're not checking the state of the database. It's a completely black box testing. We send the request and we check that, we send the adoption request and then we check that the response from the adoption request endpoint is green. It includes this request. So if I run this test, it's going to be green, hopefully. Meanwhile, I'm going to show you how we're dealing with the security. As I said, let's say when you submit an adoption request, you have to be authenticated. So what we're doing here, we're actually mocking the security, and I'm going to talk about that in a second. But for the purpose of, again, for this demo, just keep in mind that we're not actually logging into the system. We're not typing username and password. We're just pretending, we're saying to Spring Security, hey, I'm actually a test user 1 and I'm authenticated. And it's enough for the component test. But let's say if I just go to my security configuration and let's say, I don't know, remove auth to form login from here, my component test is still going to pass because, it doesn't test the form login if I can log in or not. So, and I thought it might be a good example of these edge concern. Well, actually, thanks to your advice, Bella. I think that's a great example, actually. So yeah, we have this who am I endpoint. So just for simplicity, so we have this adoption request, which are secured and protected. We also have this who am I endpoint, which is used by the front end to tell if the user is authenticated or not. So let's try to write a test for this one using the edge components. Actually, I have it already, so I'm not going to write it. So in here, I'm using the webflux annotation. And what I'm saying is I don't want to auto-wire all of the application. Instead, I just want to use this controller. And I want to import my security configuration. And by mistake, I still have this mock bin definition, which I absolutely don't need because this component is not going to be auto-wired anyway. So it's not required by my controller, and it's not going to be automatically scanned and registered. So it's irrelevant. Right, and in the test itself, what I'm doing is actually I'm using the WebDriver to navigate to who am I page. Then I'm using actually typing username and password. In the first test, I'm just navigating to this who am I page without logging in and check that I actually can navigate to the login page. That I automatically redirected to the login page. Then I check that if I type the username and password, I'm going to get my username in the response. That's the only responsibility of who am I endpoint. That's as simple as that. And if I type the wrong password, I basically get this incorrect password message. In the real world, you probably don't need to test that. That's part of the framework. You don't have to worry about it. But again, for the purpose of the demonstration, imagine you have a complex logic in your user login, like you check the email or something. So if I run that, this one is actually going to test my login. And now imagine something is broken in our security. Let's say our test users have a different password, right? So if I change that, oops. So I should change my password. And if I run my integration test suite, so we expect to see that our component test will still pass because our adoption service is fine. It's, if you somehow authenticate it successfully, you're going to be good. The adoption service is going to work just fine. But if you cannot, but we expect one of the tests for login for the slice component fail because you cannot log into the system at the moment. And that's what we get. So adoption service is doing just all right. If you somehow manage to log in, you're going to be fine. And then one slice test is failing, saying that you cannot log in using the test account we have in mind. Right. And I think we can either take a break now or maybe move to security testing.
Maybe finish the security testing slides because it's just one slide, and then we can come back to the next section.
Yeah, good idea. Yeah, probably should have been mentioned it in the beginning. We're going to have 5 minutes break. I think we mentioned that in the beginning. So let's talk about security and then have a 5 minutes break. So security is my favorite topic, actually. And I really like this quote from Rob Winch, who I think he used it once or twice in his presentations, and I really liked that. The famous words in like working on a presentation, working on a project is, we will deal with the security later. And the sad reality is sometimes that's the case for designing the test suite as well. So people like push the security into the later time, we're going to sort it out somehow later. And I encourage you not to do so because security is very important. It's a crucial part of the application. It's an essential part of the application. And to some extent, it's yet another infrastructure consideration you have in your app. So, and you can absolutely test it with Spring Boot tests. So Spring Security provides a set of testing tools and a test annotations you can use in your tests. So let's say if you just want to test your security, let's say mock a user, a currently logged in user for the whole test. And in this case, let's say if you're testing the global method security, or if you're testing a component which uses this global method security, and there is no like a real HTTP request to send, let's say, authorization header to or something, you can just use this with mock user or with user details annotations, and it will configure the security context to the username and password authentication using the username you provided. So you can basically tell Spring Security, okay, imagine I'm this user, and run all the tests, all the code using this assumption in mind. So if you want to have more details, not just username and password authentication, but something more tricky, you can also use this with security context annotation. And this gives you access to the original security context, and you can configure and set it to anything you want. So you can mock any type of authentication, any type of security, pretty much anything you would possibly want. In addition to that, if you're testing web security, which is most likely the case, to be fair, so if you're writing a test for let's say using mock MVC or web test client for your web frontend, you can totally use a set of helpers to mock user authentication as well. So it's kind of similar, but I would say if you're testing web authentication, prefer to use these security helpers. And if you're using, let's say, if you're testing global method security, you may want to fall back to this with mock user annotation. And another reason to use this helper method from security mock server configurers is that you have much more flexibility in there. You can not just mock username and password authentication. You can also mock OpenID Connect login or registered auth to client, so then you can get it in your code and then use the access token from that, well, fake access token, of course. If you're testing your resource server authentication, you can pass a fake JOT token, so you can test that the resource server configuration is working as expected. So there are plenty of tools you can use. And let's say in the example before, what we've seen is actually this. In a component test, we're using this mock user. So we're mocking the username and password authentication, which is form authentication basically. But we can also replace it to, let's say, OIDC user or auth to login if we wanted to. And then provide more scopes. We can fine tune it, we can configure it, and we can basically set it to the way we want it to be to test our security. And I think with that, I've done enough talking, and we can take our 5 minutes break.
Wonderful. Thank you. This is all wonderful and great. So I'm excited to go back for part 2. So everyone go take your break. We'll see you in 5 minutes. Thanks again. All right, we are back. Hope everyone was able to stretch their legs, get a drink of water or whatnot. Anyway, welcome back. We're ready for part 2. Super excited to dive back into it. So without further ado, Alexi and Bella, let's do this.
All right, let me share my screen this time. What a great transition, isn't it? Planned everything well, huh? Okay, so Alexi just talked a lot about how to run integration tests with all the helps from internally from Spring and like run integration tests mocking internal aspect of it. I'm going to talk more about external dependencies because unless your application is running in a vacuum, you almost always need to integrate with something you didn't write, like a database or external API. And even if you're integrating with things you wrote, how can you be sure that all the integration points or business logic are just as you remembered? The integration tests, the integration points work today doesn't mean they will continue to work tomorrow. And I don't like surprises. I would rather to have testing all the things I'm worrying about today so I can feel like have a good sleep at night. I would write integration tests to make sure my application knows how to integrate with the dependencies. And like I mentioned earlier, if I had to make a lot of assumptions about the dependency, then I would also have some external tests or enemy tests to validate my assumption against the running instance of it. Let's look at some of the useful tools to incorporate external dependencies into your tests. The first very helpful tool is with test containers. Test containers is a Java library that supports JUnit tests, providing a lightweight throwaway instance of anything that can run in a Docker container. Here are some of the common use cases. First of all, data access layer integration tests. You probably are thinking embedded H2 database is really cool and handy, and we talked about it a lot in the previous sections, but there are a lot of good reasons to test against a real database. The most necessary case is when you rely on a specific feature from a database product. For example, document store in PostgreSQL. You simply can't achieve the same goal with an H2 database. Well, not even with you use the Postgres mode with H2, you will still have problem with the document store last time I checked. Second reason, different databases or even different versions of the same database may support different keywords or syntax. Your migration script tested with H2 may not work for your production database. If you're not writing any SQL script and just rely on Spring Data to create and query tables for you, there are still chances for surprises if you're using a different database in tests versus in production. For example, date format and type restrictions. It's almost always a good idea to use the exact same version of your production databases for testing, and you should consider test containers for that. The next section, run an auth server to test security integration. Alexi just showed us how to test form login in your integration test without any dependencies. If you need to test OAuth 2 login, which is more common in production nowadays, you need to run an auth server for your integration test for that HTML unit clicking things and like typing username and password to work. In that case, you can run a real auth server with test containers in your security related tests. Our products, the one that Alexi and I work on Tanzu application service, needs to integrate with UAA server and CredHub provided by the platform. Before we adopt test containers, we have no confidence that all the security measures and resource ownership actually work before we deploy it. Test containers running auth server locally in tests was a real game changer for us. And the next use case, a scenario, is to start Docker image of your API provider. Your API provider could be an open source product or could be built by the team who used to sit down the aisle in pre-pandemic times, if you still have a vague memory of how that looks like. Testing against their latest released image can grant you better sleep at night, and you don't need to shout at them on Zoom whenever they change something and break your production. You can even run your own code in containers to test the two submodules can interact smoothly. In certain cases, you may even start multiple containers of the same code to make sure that they can successfully replicate or form a cluster of some sort. In Spring Cloud Services for Tanzu application service, we used this pattern to make sure that our Eureka servers can peer replicate securely with each other. The feedback loop we get from that was 1,000 times better compared to Bosch deploy it onto the platform and run acceptance tests. We get to debug when something goes wrong, and we gain so much confidence from it. It's pretty powerful. And here is live demo time. I'm going to show you an example of in animal rescue to change a test from using H2 in-memory database to use PostgreSQL with test containers. So which branch am I? Let me move the zoom control out of the way. Okay, so I'm on Postgres start, which means nothing has done there yet with some commented code. We're still using H2 database. Just to make sure everything works, let me just run all the tests first. My machine is struggling. Building, parsing
Blame
Java.
Zoom for that.
Thank you, Zoom.
I think our life gonna be different on M1 chips once they're released.
Cool. All the tests are passing. And now it's the exciting moment. If we just comment out this H2 database and bring in PostgreSQL for runtime so that Spring Data knows how to, we're using Spring Data JDBC. So Spring Data JDBC will know how to configure the source and the driver, which driver to use. We're also bringing in this test containers Postgres module. Test containers have a lot of out-of-box modules for some of the commonly used containers. If they have that, check their docs. It's really awesome. Like here, I only need to enable these two properties because in this data source URL, I have this TC section in the JDBC URL. So test containers knows that this is a test container thing, and it will automatically create a container, a Postgres container using the version I specified here, and make it available throughout the test. This initialization mode, I had to set it to always because the default behavior of Spring Data is to set it to embedded. So in the past, when we used H2, it will automatically inject this data SQL, create the tables based on my schema.sql, and then inject the data using the data.sql. But without setting it to always, it won't do it for Postgres. So I had to set it to always. If you're using a data migration tool like Flyway or Liquibase, you probably don't need to do this because you will always just do the proper database migration. This is one way to create a test container image. You can also create it manually, like with a static thing, and then specify the type of the container. It could be Postgres container. It could just be a generic container loading any image you want. And even with Postgres container, you can also customize it, maybe start it on a different URL and give it a special username and password. And then you can configure them here in your dynamic property source to start the Postgres, and then you set all the properties you really want to set. But for now, I should have run the test first because it takes a minute. Anyway, for now, these two properties is just perfectly fine for us to start a test container in our integration tests. And we should be able to see that soon. I'm expecting some little Docker logo here in our logs. Is the font size okay for people? I'm hoping it is because I can see, this little Docker logo. Anyway,
we're already getting some great questions on the test containers, but I think we can take them for tomorrow, leave them for tomorrow, and then discuss tomorrow. But the questions are great. Yeah, thanks everyone.
Awesome. Yeah, and if we have time, like at the end of this talk, we can also maybe answer some of them. And right now, the tests are failing. Don't panic. We prepare for this. It's fine. It's not a live demo curse. We get syntax error near auto increment. Let's see where we're using them. Of course, in our schema SQL. So auto increment is a syntax that H2 knows how to handle, but PostgreSQL doesn't know. What we want to do with this ID column is we want it to be automatically generated, and the syntax in PostgreSQL is use serial or big serial or small serial, something like that. And with this, I believe that we will get rid of the syntax error. So let's run the test again. What do you think? Are we going to pass?
I think we're gonna pass. So I'm only slightly worried about this, red underscore on animal component test.
Oh yeah,
in
it's really
IntelliJ.
weird. It says it can't find map, but all the tests are running fine. I think maybe it's just IntelliJ because I changed dependencies, so maybe IntelliJ was caching something and
So
not really.
they finally got us,
Yeah, visually, but our tests are fine, so I'm not going to complain today. And we have a lot more passing tests now, thanks to your bless, Alexi. And let's take a look at why these tests are still failing. I'm just going to scroll to the bottom and then go up from there. See the source of the problem. Duplicate key value violates unique constraint, adoption request p key. Key ID equals to 1 already exists. So it seems like when we create a new adoption request, when ID equals to null, then we're expecting database to automatically generate an ID for us, right? And it seems like ID 1 is the one that got generated by this integration. And you can see we have already 11 records in the database. So of course, we're going to have some clash. This works in H2, as we can see earlier, but it doesn't work in PostgreSQL. Just want to see how bizarre, like not using the real database is. I have no idea we will have that much trouble when we design for this. So to make this test pass, let me just copy some code from my notes. We want to alter the sequence, which sequence for table adoption request for the column ID to start with 12. And let's run the test again. We should be able to avoid all the existing records now. How about this time, Alexi? Do you think it will pass?
Drum roll. I'm always positive about it. Even when IntelliJ cannot compile my Java code, I'm still positive that the test gonna pass.
Yeah. Oh, it seems like IntelliJ still doesn't compile. It compiles.
Ooh.
Yep. A different error. Let's take a look at this time. So we make adoption request and we make adoption request to the first animal on the list, which is ID 1. And now the first animal on the list has ID of 2 instead of 1. Like this test passed, this line 113 passed, which means our animal number didn't change, but the order has changed. Like I said, different database handles query differently. Like there's no guarantee in the order when you switch to a different database. So we need to fix it, right? Well, I guess this is a question to the PM, like whether the front end is going to fix ordering or the ordering problem falls on the back end. Let's just assume in this case, front end doesn't want to handle anything about ordering and the back end is going to do it so that user is not going to see their animals start like switching on the page randomly and get completely confused. So I learned this new thing called paging and sorting repository. It's pretty cool. And what that does is when you go to, that's animal controller, when you do your find all, you can specify a sort. I'm just going to sort by ID for now. Realistically, you're probably sorting on like maybe rescue date or like something that's more tied to the animal themselves.
And I think ID2 is paprika, right? The first one is chocobo, and
the first one is
paprika.
chocobo. Paprika is accidentally removed from this sample code base, but it's still in the original database. That's paprika sleeping back there. And chocobo is my other cat sleeping in the living room right now. They sleep, they're cats. Okay, all tests passed. How awesome is that? So that's a quick demo of using like test containers. As you can see, it's really straightforward and it's not really slowing down your integration test that much. It also has some caching in between. So if you are running your test within 5 minutes, it's going to reuse the container like cached state if you choose to do so. Be careful with the state shared at that point. So that's all I have to demo with test containers. Let's move on to the slides. Spring Cloud Contract. It's another interesting topic that I love to talk about. You get a pinky promise from your API provider. Spring Cloud Contract is a collection of solutions that helps users in implementing consumer-driven contract. API providers will define API contracts in Groovy or YAML. The definitions are then used to generate a couple of jars. One of them is some JUnit or Spock tests on the provider side to verify that the implemented API conform to the contracts. You now have something to hold your API providers accountable of. Another generated jar contains a JSON stub definitions for API consumers to mock the provider API in their integration tests. The Spring Cloud Contract stub runner library can help the consumers to load the stub jar from Maven and start a WireMock server with the provided stubs. WireMock server is a simulator for HTTP-based APIs. It can be run as a standalone process that acts just like your external API server in your tests. Aside from those, you can also write your own generator based on the contract's definition. For example, if you want to generate some open API doc or BDD-style cucumber tests, you can feel free to do so. It's basically Groovy or YAML, so you can just generate things based on that syntax. So when the consumers want to request some changes from the API provider, the consumers can make a PR to the contract and define what they need clearly in the definitions. If the providers agree to do it and merge it in, then they have to implement the feature in their API. Otherwise, the generated contract tests would fail in their pipeline. It's a great tool if both consumers and producers are under active development, especially when there are multiple consumers asking for different things. It's also a good way to keep track of feature requests and can serve as documentation of the API integration points. However, it requires adoption from both ends to be cost-effective. Maintaining the contract is not trivial. If your provider doesn't support Spring Cloud Contract and you're maintaining the contract as a consumer, then you're really missing the benefit of enforcing the contract on the provider side. Let's take a look at Animal Rescue and see Spring Cloud Contract in action. Just check out the, oh, I probably have some code here, isn't it? Yeah.
Maybe while you're checking out the branch, I think the great application of Spring Cloud Contract is actually integration between the front end and the back end. And that's again why Animal Rescue is a great example.
Right. So in Animal Rescue, like right now, our front end and back end code are in the same repository. But let's assume for a second that they're owned by different teams and they're in maybe different repositories. And let's take a look at the code. So now we have this contract folder that is a big thing that has one contract defining this get animal endpoint. We want to say if we have a method, get method, don't copy and paste. If we make a get request to this /animals URL with header of application JSON, we want to return status code OK with a body that looks like this. An ID has to follow some regex. The avatar URL has to be an actual HTTPS URL. Otherwise, you'll fail this contract. And in our build.gradle file, it's fairly simple. We have this Spring Cloud Contract Gradle plugin and this Maven plugin. So with the Maven plugin, we get, let me go to here. We get an install task with our Gradle. And as you can see, our install task will trigger copy contract, generate client stubs, and verify stubs jar. And we now have this build folder, has some stubs inside. Come back here. Inside this stubs jar, we have contracts, the original contract, and then this animal.json. That's pretty much a JSON it's the stubs that WireMock can consume. Okay, so that's the contract, and the contract doesn't need to live separately. If the front end if the backend app is okay with front-end team making PR to their code base, the backend team can totally just keep the contract with the code. So you don't need to like do some dependencies and like publish in some jars before you can run your test. They can just get the contract and the backend code released together. But let's say backend team doesn't want the front-end team to make PR directly to their code base. Here, we need to still get this Spring Cloud contract plugin, apply it. And down below here, we have a contract section that describes how we want to run this, how do we want to generate the tests and how do we want to run the tests. So in the test mode, we want to say we want to use web test client. It's going to be JUnit 5. The base class here inside our test folder. This is the base class we have. It's a fairly simple Spring Boot test having web test client. We have to set web test client for our rest assured web test client because I think out of box it doesn't support web test client. So we have to add something additional. Is that right, Alexi?
I think you just need to pass it basically. So
yeah,
with this web test client,
just
you say
telling
I'm
it
going to use
to
rest assured.
Right. Just tell it to know which framework and what type of web client you want to use. And the contract
and
dependency.
You need to point this rest assured you need to point this rest assured client to your application in the first place. That's why you need to do this setup actually.
Right. So here is the steps that when we do this Maven install, it's going to put this in our local Maven repository. And then here we're just pulling it down and generate contract, generate tests based on these steps. So let's run the test. We're in the backend. I'm just going to run all the tests. Even though we only have a base class here, I'm expecting to see some surprises showing up because we have some contract plugin doing stuff.
Is it the kind of surprise I mean?
That's just exactly the type of surprise I'm looking for.
Yeah, I think you may need to run a Gradle clean because it's switched between the branches and sometimes you get a lot of old generated classes and sometimes
let me do a Gradle clean and then run tests.
So you're going to get a pleasant surprise.
Small surprises. It's okay. Live demo never goes well. Okay. Copy contract, generate contract tests. That's something new we didn't see earlier with the contract module. Look at this first test. Has a really, really, really long name. All tests passed. So let's just take a look at this first test. Go there. Yes, we're here. You can see that this test is based in this build folder. It's no longer in our code. It's generated by the Gradle plugin. And what it does is it's pretty much making a web, it's using the BDD style, using given, when, then, and certain things should happen. It's using the web test client we give it to do. Right. Yep. Given this request, doing the get request at animals, we want the status codes to be 200. The header has this, and the array should contain all these things that matches the regex as we specified in the contract. And all this is generated. We don't need to do anything about it. It's just there. And let's look at the consumer side. In the front end, we have HTTP client. This get animals call will use this HTTP client to do a get request at animals, sending in these headers. So this test is using the Spring Cloud contract stub runner. This module is actually published just by Alexi for the sake of this talk. It's a JavaScript library that runs wiremark as a standalone package and then consumes the Maven package in memory here. So here we're saying run stubs using this artifact on the port we specified here, 8088. we set the backend base URL. So the backend, whenever the HTTP client calls the backend, it's going to call the WireMock server instead. And we just call this get animals and making sure all the things comes back. Can also run a quick run to show that it's actually working. We didn't lie to you. Well, you can also check out the code and see everything is working. We don't lie.
Yeah, the first run actually may take a while because this library needs to download the dependencies and download the jar file for the stub runner itself. So it can take a little while to start and download everything, but once you have it, it's going to be much quicker.
Cool, we passed. That's great, isn't it? That's all I want to show about Spring Cloud Contract for now. But like I mentioned earlier, if your API provider doesn't support Spring Cloud Contract, it's not cost effective for you to maintain Spring Cloud Contract as a consumer. If that's the case, you can skip the contract step and just write your own stubs for WireMock in your integration tests. So let's take a look at an example of that. Let me just check out Partner Adoption Center. In this case, let's assume that all the adoption requests are stored and managed by another adoption center called Partner Adoption Center. And it's a very old school API. It doesn't support Spring Cloud Contract. In fact, it doesn't actually have much test because I didn't write them. I'm sorry. That's not the point. The point is the backend. Because we're calling an Partner Adoption Center now, our adoption service no longer stores adoption request or takes adoption request from our database. It now actually make web client calls going out to an API, our adoption center. And the adoption center URI is injected with this value going to this web client as being set as base URL. So let's take this delete method as example. If I just tell it to return a mono empty and run this adoption service test, let's see what happens. So here I have this delete adoption test, which gets a test request and then just call our adoption service with that request. We have some verification here. I think I need to do a clean again because we're constantly switching our dependencies.
Yeah, IntelliJ is fairly unhappy about that.
At least it compiles this time. Okay, let's run this. Still no.
Maybe better luck with the command line if you just run it there.
Good point.
Guess it's not that visual as IntelliJ, but still, at least maybe there's something that's going to work. I feel like, we're using our luck one by one, that in the beginning, the demo was great and everything worked. Everything was perfect, basically. Then, the little kind of flakes and glitches, and now, IntelliJ cannot find tests anymore.
Yeah, the curse is there. It's just a matter of time and when it happens.
Exactly, yeah. We have a limited, the limit of luck, and we just spend a little bit during the demo. So I guess by the end of the this demonstration, we should have problems with the, streaming and video, audio, and everything. So
yeah, and cats jumping on the keyboard. Cool. We get our failing test. Thanks for the stalling, Lexi. Our WireMock server is complaining that we expect to see a delete call at this URL, but it's not happening. Because in our verification here, we actually have, we actually tell it to verify there's a delete call at this URL with all these query params. And that fixture you're seeing here is actually a JUnit 5 extension that I registered here. So it will have, just think of it as representing the Partner Adoption Center in our tests. It's a fixture. It holds some data. It holds a WireMock server that will start before all the tests, reset all the mocks after each test. And after all, it will shut down the wiremark server. And when we set up this wiremark server, we also using files under this class path, which is under this wiremark folder. And that's the wiremark folder here. We have, so by default, when you use this use files under class path or use files under file path, it will automatically look for a mappings folder and just load all the files under that mappings folder. Just like if we're using a stubs coming from generated stubs from Spring Cloud Contract, it's the same format. You have a mappings folder and with all the stubs underneath it. So this is exactly the same thing as the generated one from the previous branch that I showed you earlier. That's why when we run the test, which test? This test, sorry. That's why when we run the test, we don't need to explicitly say mock stop this call because it's automatically loaded under that class path. So we have a failing test. Let's just put our code back. And it should pass. I'll just leave it run on the side and we'll come back and check it later. Because I just showed you how to set some static stubs, but I also want to show you how to set some stubs with some dynamic data. Like for example, this stub is is reading some response from a file, which is this file. It's just a response body coming back from it. And you can also potentially like construct your own adoption request and pass it in or like modify it. Yeah, it's pretty dynamic. It like you can just do all sorts of things with it. Another thing I want to really mention is that you can see we are using this .block section. It's because now instead of taking it from the database, we're making HTTP call, and in Spring, I think after 5.2 or 5.3, REST template is now deprecated. Oh, maybe this is not a good example of doing the commenting out, the deletion. Let's come back to deletion. So if we just comment out this block section, what do you think is going to happen?
I bet it passes.
Right, if IntelliJ let us to do so. No. Oh, the previous test all passed. So because we commented out block, this is a reactive code. This is generating some reactive event. It's a publisher, but we're not subscribing to it. So there's no guarantee that this is going to verify. There's no guarantee that that task is going to be executed anywhere. The test will fail. It failed.
All right,
Great.
all right, I was wrong then.
You know that. So blocking is just a good way to check the output of a publisher just by simply subscribing to it. However, blocking doesn't really doesn't test the reactive nature of the publisher. If we want to do something more complex, like checking on the stream of output, or need to verify something with time, making sure that sometimes it's a healthy emission, sometimes it's an exception, you need to do something more advanced using step verifier. Like I have a step verifier here saying calling adoption service.add, and then we expect to have an error out of it. That's also just a simple example of like testing with a mono publisher. And a more interesting example is actually this one I found out that I really find really interesting, I want to share, is with virtual time. You can say, I want to have a mono that return hello after 20 hours. And I expect the first 10 hours to show nothing, no events. I'll wait for another 10 hours and I expect to see hello. And I can actually just run this test without waiting for 20 hours. Isn't that awesome for some cron jobs you have? Oh yeah, I can't run this in IntelliJ, of course.
Yeah,
It would just
waiting
happen.
for 20 hours is not fun.
Right, exactly. I remember in old days when we have some cron jobs, like doing some data migration at midnight, it's very hard to make sure that we actually have the time configured right. Or if you are event producer, like you're supposed to send out an event every hour or so, this is just perfect to test that time with virtual time. And I don't know which one is that. I think it's the
It's the
sample
first
step
one, I think.
verifier. Yeah, you can see that we didn't really wait for 20 hours. Yeah, that's pretty cool. Okay, I think that's all I have here. Let's come back to slide. And we come to acceptance tests. We're getting onto the cherry on our trophy. Acceptance test or end-to-end test. Oh, sorry, we were using end-to-end test in the previous slides, and now we switch to acceptance test. We use these terminologies interchangeably just because like it's all from user's point of view. We're thinking of this as the gate, the final gate before our code can walk out of the door. So acceptance test or end-to-end test, they should be as realistic as possible. We should use real environment, real infrastructure. We shouldn't use mocks. We shouldn't use interceptors that like interject into our any method calls in our code and checking on state of certain things. And acceptance tests usually require more setup and tend to be more flaky. So we should only test critical path. Think of the essential joint for your application to work and just test that, especially the ones that are not well tested with integration tests, like infrastructure, for example. And imagine it's your user trying your app. This is the best place for behavioral driven development tools, BDD, like Cucumber. Given an initial state, when user performs an action, then there should be some perceivable outcome out of it. And be aware of shared state. Try to design your user journey to perform a full loop. If they create something, then as a real user, they may want to delete it afterwards. Just leverage that in our test to reduce the leftover states as much as we can. And if your application doesn't allow a full loop for your user, then you either need to make your acceptance test more resilient to dirty states or have something in the middle to clean up state in between tests. I think we have enough time to demo our acceptance test in animal rescue, so I'll just quickly do that. Hopefully we have enough time. So for animal rescue end-to-end test to run, we need to have all the application running. And also on the end-to-end section, we can start Cypress. Cypress is the end-to-end testing framework, JavaScript end-to-end testing framework that we use. It simulates user input with real browser. Yeah, it also records video or like takes screenshots when something fails. It's pretty cool. I opened up on a different screen. Something's happening.
Yeah, I think it's
not sure
especially interesting to watch how the machine is typing the usernames and passwords and everything into your application. It's kind of fascinating to see. I just like to watch it really when I run into acceptance tests.
Right. And it started. You can see we show animals on adopt buttons disabled. We just logged in and we typed in a bunch of stuff. It's happening too quick. I can't really follow up that speed, but as you can see, it's all from a user's point of view. The apps are running on the background, but we have no interception into any of the calls or anything. It's all like judging based on the state of here. So this is just a great tool for end-to-end testing if you have a front-end piece. However, some of us are making tools for developers. We may not have a front-end piece. Maybe the backend itself is your product. Then in that case, I would argue that this animal component test can be just seen as end-to-end test. Well, if we're not mocking this user, then we can just treat this as our end-to-end test and making sure that everything works as expected. If we just swap out this mock user with the URL, like HTML unit loading the page, putting in username and password, then this is completely from a user's point of view. Excuse me. user point of view because we're just making a request and then we make another request, making sure that our previous request actually did something instead of checking the database. Cool. Is there anything to add on acceptance test, Alexi, on these slides, on this demo?
Just wanted to add quickly to this API as your acceptance test, API layer as an acceptance test. So in most cases, like if your API is your product, you won't need to use any mock users or mock something, because most likely they're gonna be some sort of API security, like a token based or auth based or something. So you will have, as a consumer of your API, you will have a way to authenticate using a token, and this can be tested as well in your acceptance test suite against your APIs. So you don't have to type username and passwords, most likely, if you're using these testing APIs.
Right. Yeah. The whole idea is just to use the real security exercising every piece of your code without mocking anything. And that's all we're asking for. It could be looking very similar to component test. So you might be asking, you may wondering if we still even need integration tests. If we're doing API, we don't have front-end piece, it's just one piece of code that we want to exercise. If we just have solid acceptance tests, do we still need integration tests? Well, let's look at some of the drawbacks with acceptance tests. Acceptance tests failures are sometimes very abstract and hard to debug. To effectively do TDD, I would like to see the failure message to tell me what to do next, and I will just do enough to make it fail differently. But with acceptance tests, a lot of time, because it's from user's point of view, you just know that it doesn't work, but it doesn't give strong signal on what to do next. And the state of acceptance tests are sometimes hard to manage. We mentioned in the previous slides that we need to design the tests carefully to avoid state contamination. It might also be hard to cover all edge cases because we're testing from outside of the box. We can no longer intercept the calls and supply variations of stubs for all edge cases. Imagine doing that with an orchestra worth of microservices dependencies. I think I might just choose Go farming instead. And more failing factors that may distract you because we're integrating with a real infrastructure and dependencies. Our tests could fail due to insufficient resource or internet going slow, or browser resolution is different from what you have on your local machine, or asynchronous update, you're not just waiting long enough. All these sort of errors can actually distract you from finding what the real problem is and may actually make you think that your code doesn't work, where it probably does, just not as fast as the test would expect. So the test can get flaky and fail for other reasons. That's just another reason. You don't want to just rely solely on acceptance tests. However, the shape of the trophy all depends on your application. If your app is really simple and self-contained, if your app doesn't rely on any complicated infrastructure, then maybe a flat top trophy is just perfectly fine. In fact, the animal rescue sample app was started that way, and there was only acceptance test and nothing else not until I started adding logic to the backend. I didn't have any test in the front end or the backend. And if your application, on the opposite side, if your application have a lot of intensive business logic or heavy on calculation, then maybe you actually need a fat belly trophy where you need a lot of unit tests, testing those specific edges that you want to make sure that they work perfectly. And then you use integration tests to pin them up. And that could be a fat belly trophy. As long as you cover all the grounds and understand the risks, you can define the shape of your trophy. And that's the idea I want you all to walk away with. Okay, wrapping up. Alexi, do you want to do this part?
Yeah, sure, I can do that. So yeah, thanks, Bella. I think that's great. You get now you all get this idea that what the testing trophy is, and you also get an idea that testing trophy is not ultimately the most important thing, because in testing, I would say the important thing is confidence. So the whole purpose of you writing tests for your software is giving you confidence. So basically, if you can take your so the testing trophy approach can be a good alternative to a test permit. It gives you a lot of flexibility in refactoring. It gives you more confidence. But ultimately, whatever the approach you choose, basically do make sure you not end up with the situation like that on this picture, that you have a lot of independent tests passing, but in the end you get the system which is not working for a user, because the user is the ultimate consumer of your application. So make sure it works for the user. And I would say write any shape your test suite in any possible shape that works for you, that gives you confidence. And I would say ask yourself a question like, can I take, if my test suite is green, if my CI is green, can I take my application and deploy to production? If yes, you have a good test coverage, you have a good testing pyramid, testing trophy, whatever it is, if you can deploy it right after your CI is green. If not, then try to ask yourself, why not? And try to focus on that. And whatever the tool you pick, integration tests, end-to-end tests, unit tests, just use whatever works basically. And then in this case, you can switch from this, set of independent tests which don't give you any confidence to a testing trophy, and you can eventually you can win a testing trophy in whatever language and whatever platform you are using. Yeah, and this is the last one. Basically, this is from the Kent, a quote from Ken Dodd, which kind of started the whole movement of testing trophy. I think it's a title of one of his articles, which I really like. It goes as write tests, not too many, mostly integration. But write test goes first, so keep that in mind.
Yep.
Cool. Yeah, there are a few links actually that can be helpful for you to follow up. So the link to the repository is, as I said, is github.com/alec-cis/animal-rescue. So this is the repo with all the source code with a couple of branches you can play with. You can switch between branches, run the tests, run the integration tests, end-to-end tests. So everything should be runnable. If you find something that it's not working as you expect, feel free to create a PR or just get in touch with us. So I think the kind of the ultimate starting point, if you want to know more about testing trophy approach, which I think is focusing more on JavaScript, but it still gives you an idea of what it is. It's this testingjavascript.com website, which is created by Ken Dotz. And the article I just mentioned, write tests, not too many, mostly integrational, is also in Ken's blog. So you can read that. If you want to learn more about London School versus Detroit School, which sometimes, by the way, you can see as mentioned as a Chicago TDD school of TDD, which is kind of the same as Detroit School. It's a classicist, which I don't know why, basically, there are two names for that, but surprisingly, I think it's 50-50 split. Some people call it Chicago School, some people call it Detroit School, but London stays London School all the time. So, yeah,
you stay there. I may move.
Yeah. So you can learn a little bit more about on this link. And yeah, if you have any questions or ideas, or feel free to use this Q&A section in this streaming. In this stream. So we're going to take most of the questions, I think, and answer them tomorrow, because we're going to have another hour for Q&A tomorrow. These are great questions, by the way. Thanks everyone for participating. If you have more questions or more feedback, even after the talk and after tomorrow's Q&A session, feel free to get in touch. Basically, message us in Twitter or in GitHub or like in any possible way. Basically, we're always happy to chat, because I think we spend quite a bit of time just discussing the different ways of testing and comparing and arguing about different ways of testing. And I would say I really learned a lot actually working on this presentation. So.
Yeah, and I really think that our software community doesn't need to fight all the time, because our goal is to write good software. As long as we can reach to a common ground, have some key principles that we all agree on, we don't need to fight. Like all those different patterns, they're tools to help us solve our problems, specific problems. There's no one method fits all. So we need to think more on what we can do, and we need to think more on what's best for yourself. Awesome. I think that's all for today.
Great. I'm back in. I'm here. That was incredible. And yes, now I just imagine Detroit and London going like, my testing testing is better than your testing. Your testing isn't good. You leave me alone. I don't know. I just
You're the best,
two cities.
Bob.
Two cities going to war over testing. But no, you're right. I actually, that's kind of just been a motto of people, particularly in this business unit from VMware, is like, let's just make software better and make it better for everybody. And of course, the testing is such a huge part of that. And so, thank you all, both of you, for sharing all the different ways of looking at it. And again, you're right. It's like, not everyone is right for all of it. Like, you have to figure out which case is best to use for which purpose. So hopefully we will address a lot of these questions tomorrow. Like you said, Alexi, they've been great questions coming in. Thank you, Yvonne, for answering what you can and also saving some for tomorrow. We really look forward to that. We look forward to that 9 a.m. tomorrow morning. Again, it's going to be an hour of Q&A. And so if you didn't even get your Q in now, excuse me, easy for me to say, you can certainly ask them again tomorrow too. So don't worry, if you didn't get into today, you can still have the Q&A open tomorrow. Reminder, today is also KubeCon, so you might be split screening right now looking at KubeCon. So get all that knowledge of KubeCon in today and the next couple days. But definitely come back tomorrow from 9 a.m. Pacific to 10 a.m. and we'll have that Q&A happening. We've got lots of great content, all of our previous spring shows and Tanzu Tuesdays and Armchair and Keyboard and Tanzu Talks. You go to tanzu.tv and you can check out all that great content. And so we're just happy that you joined us for the last 2 hours. Thank you so much for your attention, your questions. And again, we will address those tomorrow. Use the same link that you got emailed. And yeah, we will see you all tomorrow. Do you have anything else, Bella or Lexi, before we sign off?
No, this is awesome. Thank you, Bob.
Yeah, thank you. Thank you very much.
And thanks everyone for joining.
Yeah, we look forward to another great day tomorrow morning for us, and for Alexi, another great afternoon, and Bella right in the middle. You're going to be missing lunch, but that's okay. You can have a late lunch. All right.
All right. I'll celebrate after that. Thanks.
That's right.
Tomorrow.
See you tomorrow.